All right, so let's talk about a problem involving Coulomb's law with angles. So let's do kind of the same setup of the one that we did in class, the one that's in your homework. But in this case, I'm going to make all of them positive charges. And this is going to be 5 microcoulombs. This one is going to be 6 microcoulombs. And this one is going to be 4 microcoulombs. Remember that micro means times 10 to the negative 6, whatever. In this case, it would be coulombs. So we have distances here. Make this one 6 centimeters. I'm going to make this one, let's see, 8 centimeters, and that makes my life easy because this is a Pythagorean triplet, which makes this 10 centimeters. Okay, we already know that we're going to have to figure out this angle because we are having vectors at an angle. So we can do the inverse tangent of 6 divided by 8, and it doesn't have to be tangent. You can do whatever you want to, but tangent is opposite over adjacent. This is the one I like to use. So the angle here is going to be 37 degrees. Okay, it's 36.9 something or other, but I'm going to make it 37. So let's talk about forces that are on the 4 microcoulomb charge. This is the one we are looking for in terms of net forces. So that particular charge, the 4 microcoulomb charge, it has one repulsive force from the one to its left. We're going to call that one A. So I can call this one the force from A. And then this one is going to be called B. So I can call the repulsive force from that one from B. So, or F from B. And because of the fact that these angles are going to be alternate interior, we can also know that that is 37 degrees. So we can start calculating. FA, according to Coulomb's law, would be K, QA, QC, if I call this one C, is divided by R squared. Writing that out in gory detail, we have 9 times 10 to the 9th multiplied by QA, which is 5 times 10 to the negative 6th, multiplied by 4 times 10 to the negative 6, and then we're going to divide all this by, working in centimeters, so 0.08 centimeters, or meters squared. Okay, and if you put that all into your calculator, you get 28.13 newtons. All right. So we continue on and do the exact same thing for FB, and that is going to be, again, KQ Q over R squared, dealing with QB instead of QC, and dealing with the distance between them. So 9 times 10 to the 9th multiplied by 5 times 10 to the negative 6 multiplied, no, excuse me, we're not dealing with 5 anymore. I was just recopying. This one is going to be dealing with 6 times 10 to the negative 6, and C stays the same, 4 times 10 to the negative 6. Sorry about that. And then the distance between them, because it's 10 centimeters, is going to be 0.1 squared. So when you put all that together, you end up getting 21.6 newtons. Notice how they're very similar to each other. B is a little bit further away, but it also has more of a charge to you, or to exert force with. All right, so now we have something that kind of looks like this, where we have a vector that is going to the right, and it is 28.13 newtons, and we are adding to it a vector that is going up and to the right of 21.6 newtons. So what we are going to have to do is find the x and y components of this one in order to get the actual resultant vector. All right, so to try to figure out what these components are, we need to know the fact that this is a 37-degree angle. So to get this side, this is the opposite side, so we would use sine, so this would be 21.6 times the sine of 37 degrees. And if you put that in your calculator, you get 13. It would be 13 newtons. The one here is the adjacent side, so that's 21.6 times cosine of 37 degrees. And on this one, we get 17.25 newtons. Okay, so continuing on, we put all of the vectors together that we now have. Now keep in mind what we have now is the one that's going this direction at 28.13 newtons. We have another one that tacks on in that direction that is going 17.25 newtons, and then one going up at 13 newtons. So the actual vector that we want is this vector right here. Okay, putting these two together, we get, I don't even write that down, what I can do in my head. 25 and 13 is 38, and let's see, 8 and 7 is 15, so 45.38 newtons on this side, and 13 newtons here using the Pythagorean theorem. You would end up getting that this is 47.21 newtons. So that is part of the answer, right? The net force is equal to 47.21 newtons, but we still have to figure out this angle right here. So switching gears a little bit, we can do the inverse tangent or whatever side that you want, sine, cosine, whatever, and inverse tangent of 13 divided by the 45.38 newtons does give you an angle of 16 degrees. So this would be 47.21 newtons at 16 degrees. And in this case, if we consider to the right as being east, this would be north of east. And there's your answer.